So converged broadcast and IP platform. This is kind of an easy topic because who doesn't believe in converging broadcast and IP, especially in the context of NextGen TV? I don't think anyone pushed back against this. And, you know, basically this is, there was a war between Internet Protocol and the rest of the world on how to organize digital signals, and guess who won? IP won. MPEG-2 is a great thing for digital television, but it is not a forward-thinking structure to base a new standard on. So you're going to see this slide probably again somewhere, but IP is the key to connectivity in the connected world, full stop, period. And ATSC 3.0 entirely relies on IP as its backbone. From the Department of Redundancy Department, you saw the software stack previously from Madeline, and understanding everything in it really isn't necessary. There's only two paths through this thing, and one is for broadcast signals and one is for broadband signals, and no matter how you go, you got to go through IP. So it is a fundamental and foundational part of the ATSC 3.0 standard, and that's a good thing because it allows you to do a lot of things easier, but it allows you to do things that you really couldn't do before, like so-called hybrid delivery, having some parts of a service be delivered via broadcast and some of them coming by broadband, and doing that in a synchronous and seamless way that is combined in the receiver makes a lot of sense. So there are use cases that you can either fabricate in your mind or see replicated in an analogous way in other services, but being able to send an alternate language, for instance, a soccer game, and you have 3 or 4 different languages, but not take up your precious OTA bandwidth to do that, rather send 1 or 2 over the air and have other alternate audio kinds of announcements in the broadband channel. You can also do targeted ads. You can do targeted ads and send them over the air, stored locally in the receiver, or you can make them available by broadband and insert them at the appropriate time. If you look at other parts of the world, catch-up TV is a big deal because people are usually late to watching a show and they want to catch up and start over. So having broadband integration is a tool you can use to affect that kind of use case. The idea of handing off from broadcast to broadband is a nice theoretical construct. I don't know that we'll actually do that. We talk about that in radio too, by the way, these days, of going back and forth from broadcast to broadband. Well, it's a possibility. It may not be the first thing we do. I think one of the most interesting use cases is the last one here, having a basic service that you deliver over the air and an enhanced service layer via use of layer division multiplexing and scalable HEVC encoding, for instance, to deliver an enhanced experience over broadband. And oh, by the way, you might charge more money for that. I realize we're in public TV here, so I'm not supposed to talk about revenue so blatantly, but one way or another, having differentiation by exploiting broadband is a very good thing for over the air. You also get away from the tyranny of real time with the enhancements of broadband and broadcast together. So you can do things in real time just as we do now, but you don't have to. You can do things either on a pull basis, demand basis, or via local caching in the receiver. That can be application files, it could be targeted ads, it could be certainly in the emergency application, the use of maps and additional stories and things associated with a very timely presentation of emergency management. But basically, the difference between ATSC 1 and ATSC 3 is not that we don't have broadband and internet associated with television, because we do now. We have smart TVs, and they are connected to the internet and they work pretty well, and they're also able to pick up and display broadcast signals. But there's a wall between the two. There's no communication in any smart TV really that allows you to do much. A little bit, but not much at the same time on that screen. You don't interact with broadband at the same time that you're watching television, or you don't. One doesn't affect the other at any rate. But with ATSC 3.0, with its IP structure, you can really talk about now you are part of the internet, or the internet's part of you. It doesn't matter, but it's one system. That's the point. Is that with the addition of making sure that the signal is secure and that you can manage the rights associated with that signal. You can make money from it and not worry about it. You're not going to have indiscriminate retransmission over the internet. Anyone remember back to the broadcast worry days? This stuff's going to be secure, and you can do file delivery, so you can do video on demand. You can do dynamic ad insertion. You really take advantage of the things that are available in the internet without increasing the risk of piracy and bad things that are associated with the internet. So broadcasting no longer an independent silo that you have to be an expert in ACAP, and remember various interactive kinds of attempts years ago. And you can take advantage of the fact that internet protocol stuff is evolving at a very fast pace, and anything that happens in internet also will now apply to broadcasting for the internet active portions. So you get these new hybrid services. You get to incorporate new kinds of things on a niche basis or on a mainstream basis, and new business models, and that applies for both public television and for commercial television in one way or another. So a few examples of that that have been used, and you're going to see a number of these, and Richard Lermit after me will show you some of the practical examples of what can be done. But a sports replay kind of application where you show highlights of a game, especially when you're joining the game late and you want to see the one and only goal that took place in the first period, those kinds of things. So having overlays on top of the video that are personalized for what you want to see makes a lot of sense. The idea of offloading stuff onto a companion screen in the modern living rooms of today, people are watching maybe the same content but on different screens, and certainly tablets and phones are a big part of that, and with gateways like DigiCap has talked about, that's going to be very feasible to do, and you can tailor that companion screen experience for the person who has a personalized interest in perhaps different audio. Hopefully they're wearing headphones so they're not going to bother anyone else, but a number of personalized tablet-like experiences can be made feasible very easily with IP. Again, the main difference, ATSC 1.0 and 3.0, is you got one screen in ATSC 1.0. You want to put graphics on there, fine, but you burn them in, everybody sees the same thing, and you do that at the production end. With ATSC 3.0, you're dealing with an overlay environment, very similar to all the laptops and things you have out in front of you today. So you can have hybrid delivery, and you can have different content for different parts of the audience, even though it's a broadcast audience, and theoretically that's one to many, but it can also be, and on an overlay basis, one-to-one. So you can have interactivity, haven't really had that before, personalized graphics, hadn't had that before, synchronized with second screen stuff, and also the internet gives you a very good way to measure the audience on a second-to-second basis, and all the problems with the traditional measurement systems are kind of made moot with the introduction of the internet. So there are all these features of having an HTML5 based environment, but the most important one really is the one that's in bold at the bottom. This is based on World Wide Web Consortium technologies. So you align with the web as much as you possibly can, and that means those thousands and tens of thousands of programmers and technologies that are geared towards the web be part of the broadcast television experience as well, and leverage that so that you can do a write once and publish many application that includes broadcast TV. That's a big deal, and by and large, broadcast stations, certainly groups and networks, have very large digital departments already that are programming for the web, and they don't have to learn anything extra to publish those same kinds of applications to broadcast with an IP infrastructure. So this convergence all makes a lot of sense. At the consumer end, you would think, well, we got to teach people how to deal with broadcast and broadband in the same device, and that's not really true. They're already here. We've been prepping people for this for years. We have hybrid broadcast and broadcast reception devices. They just don't do all that much. We recently subscribed to a new statistics service, so I kind of went nuts and created a few charts. And I'll just blast through them here. This is all from Statista, which pulls from different sources that do forecasts and various kinds of lies, damn lies, and statistics. But in asking which of the following features does your main TV have, 60% of people say they have a smart TV. So this is not a niche thing out in the wild. Over half of the consumer population with a television set has a smart TV function in it. The follow-up question from that is always, yeah, they have it, but they're not using it, right? No one connected to this stuff. And the fact is they are being used, and that usage is increasing. For the question of what device do you use to watch online video on your television set, according to internet users 2018, 2019, and most people say, oh, I use Fire TV, or I use Roku, or I use Amazon, or I use Chromecast. The dominant method of watching online TV on a TV is the TV. It's the smart TV with its own online video app, 35%, and it's gone up. So people that say these smart TVs, no one's connecting with them, it's a clunky interface, and get an Apple TV, that's the only thing for you. It's not true. They're getting more popular, and they're getting smarter. The number of connected TV viewers, however you define that, but the number is going up from 2016, 153 million users that identify as connected TV users, and you can see as you go up towards 2023, it starts to level off, but you're well over 200 million users at that point. So this is a growing thing. All these charts are the same. They're all going up to the right if you organize them properly. So this is a increasing thing, except for cord cutting. Cord cutting is well, it's going up and to the right the way the way I've stated it here. More and more people are getting rid of their traditional pay TV service. Yes, retransmission consent's very important, but the trend is people are not as happy with these all-you-can-eat bundles anymore. So cord cutting is getting real, and it's increasing, and more people are accessing broadcast television over the air, partly as a result of cord cutting. But over-the-air TV viewing is growing. These happen to be Nielsen numbers. There are a lot of studies that all show these same kinds of things. So we can quibble, if you want, over the percentage numbers, but there's really no quibbling with the slope and the direction of the curve. In Nielsen, you had 11 million homes back in 2010 that were over the air, and now you have 16 million homes, and they break into two categories: those that are only broadcast TV That's the only way they get television, and that's a relatively low number. But you have this new category of broadband-enabled over-the-air homes. These are the cord cutters that are getting broadcast TV over the air, and they're getting broadband TV as well through the internet. And the two of those together are just fine for them. They don't need to have 7 ESPN channels. So it's growing. So smart TVs been a category that's out there for a long time, and in many ways we've been learning a lot as smart TVs, and ATSC 1.0 has been a part of that learning process as the student ATSC 1.0 smart TV morphs now into the graduate student of ATSC 3.0 with NextGen TV. So smart TVs are now almost done with their education, but now they're going to have to go to post-grad school and figure out other things. So that's kind of my intro to Richard Lermite from Enhancements, who's going to talk about the technologies they have and how you actually implement a lot of the interactive kinds of features in data casting. So
That's
turn it over to Richard.
Great overview. And